What's going on, everyone? You're back with Jono for another quick math lesson. Today we're going to look at the cosine rule. Again, talking about non-right angled trigonometry and finding out unknown sides or unknown lengths, just like we did in the sine rule. But this time we're basically just talking about Pythagoras' theorem with a little bit of extra stuff at the end. We're just going to look at how changing a right angle impacts the opposite side and why the cosine will work for us to find the changing angle or the changing side length. So if I start with the right angle or 90 degrees down in that bottom corner, if I topple over that A point, if I push it over, that's going to make the angle smaller. Even though I'm not changing the length of the arms, we can see that that opposite side length has to become smaller as I close it up. And then as I open it back up and make it larger than 90 degrees, the opposite side length still increases. So we can say obviously that as the angle changes, the opposite side moves in relationship to that angle. And also what's really important is the size of the arms. If it was a really, really small triangle, then that side length, the opposite side length, would also be really, really small. If it was a much bigger triangle, that would matter as well. But the important thing we need to know is that from 90 degrees, if we change this, the opposite side of our original angle will change as well. The important thing that we need to know is that there is a relationship between the opposite angle and its opposite side length. These two things are completely matched. As the angle gets bigger, the side length gets bigger, and as the angle gets smaller, the side length gets smaller. Knowing that this opposite side relationship exists is incredibly important for the cosine rule. So what we need in order to determine the specifics of the cosine rule, what is the angle and what is the changing side length, what we need is an included angle. So an angle that is in between two sides that we have information about. If we have that included angle and we know how long the side lengths are or how long those arms are, we can find out all we need to know about the size of the angle or the size of the opposite side. So having the included angle and two arms is all we need in order to get these right. So the formula is that c squared is equal to a squared plus b squared, Pythagoras, minus 2ab cos c. We're just going to write down exactly what each thing means in this equation, just so we exactly know what we're talking about. So the c squared is our opposite side length of the angle that we're given. So c squared is opposite side. The a squared and the b squared are the two arms that hold in the included angle. So these are our two arms. Just make sure we know that because it's a squared plus b squared, they can go either way. It doesn't matter which one's which. And when they're in that minus 2ab, because they're all multiplied together, again, the order does not matter. And finally, the cos c is that included angle that's in between those two arms. So everything's going to be on one side of our triangle. All the information's on one side, and we're going to have to find out, hey, what's all the way on that opposite side? So just a little note about the minus 2ab cos c. It's actually really important that we link this back to our unit circle knowledge. So remember, when cos is in between 0 and 90 degrees, everything, cos, sine, and tangent, are all positive in that first quadrant. So that means that cos is a definite positive number. But because of that, because the formula for the cosine rule is minus 2ab, if we have a negative number times 2ab times cos c, that makes the whole thing become smaller because the numbers are all positive multiplied by that negative at the top. So the side opposite our angle that is included becomes smaller. And that makes sense. We've said that the smaller the angle, the smaller the side length, and this is why our formula gives us that correct answer. When cos is exactly 90 degrees, cos 90, if you type that into your calculator or you know your exact values, we actually know that that's equal to 0. So it is 0. And that means that our side length doesn't actually change. So it is just Pythagoras' theorem. So when there is a right angle, instead of having to write 2ab cos c, that whole thing becomes 0. So we just have good old c squared is equal to a squared plus b squared. So this stays the same. Finally, if cos is in that second quadrant between 90 and 180, or it's an obtuse angle, that means that it is a negative number. Because the whole thing is multiplied by the -2 out the front, the entire equation becomes bigger, meaning that as that obtuse angle opens up, the side length becomes longer. So we're just going to have a look at a couple of examples. Most of this is just chucking stuff into your calculator once we've identified the included angle and the two arms on either side. So for this one, our c squared is on the opposite side, that x that we don't know. So x squared is equal to a squared plus b squared, doesn't matter which one, but we've got 14 squared plus 13 squared minus 2 times 13 times 14. And then finally we have cos c, which is just cos 72. If you just type this into your calculator, that is half the battle. So when we type this in, we get the answer 252 point stuff. Don't round it yet because we don't have our final answer. We have to remember, just like with Pythagoras, you have to root your answer. So in your calculator, if you just hit root ants, we have our final number is x is equal to 15.89. This kind of fits in with that triangle. 13 and 14 are the other two side lengths, so we know we're probably on the right track. If you do get an answer that's crazy out there, like 252, make sure you don't just stop. Make sure, have a look, see if it fits in with everything else. So that is all the working out that we have to do for these ones. These are usually 3-mark questions. Bang, if you can use your calculator, you're going to get these right. Now it is a little bit harder if you are searching for the included angle. Some formula sheets give you the angle formula if you need to use it, but we're just going to see it's basically rearranging equations. So if I've got this one, I'm just going to throw in my information to start off because I prefer to move numbers around, but you don't have to do that. So if I've got c squared, it has to be the opposite of the included angle. So c squared is 11 squared. This is different to Pythagoras. Pythagoras, it's always the hypotenuse or the longest side that's by itself, not in this example. So if I've got 11 squared, that's equal to 32 squared plus 27 squared minus 2ab, so minus 2 times 32 times 27, so they pop up again, multiplied by cos of our angle. So this time our angle is hanging out there at the very end, kind of embedded in all this stuff. So we've got to move everything else that's not multiplied over first. So I'm going to minus 32 squared and 27 squared onto the other side. So this becomes 11 squared minus 32 squared minus 27 squared is equal to the -2ab cos c, or -2 times 32 times 27 cos theta. So you can just type everything into your calculator just so you get one number. I actually prefer doing that. So that means that on this side we've got minus 1632 is equal to, I can make that -2, 32 and 27 multiplied together to give me one number. So that's minus 1728 cos theta. We can see pretty easy what you actually do here. You've got to divide off that number. So to get cos theta by itself, and I'm just going to put this over this side now, I had to divide the -1728 to the other side. So that gives me the answer of 17 over 18. So just to get that by itself, I've got theta is equal to cos -1, 17 over 18. Throw that into your calculator and you get the answer of 19.19. So I know that this is a lot of rearranging and that is quite annoying. You might just be given the formula on your formula sheet. So the cosine rule formula for finding an unknown angle is that cos c is equal to c squared minus a squared minus b squared all over 2ab will get you the right answer. It's really important though that the c squared at the front is the opposite side. So the thing that's positive is opposite the angle you're trying to find, and the two negatives, minus a squared minus b squared, are the arms that hold in that included angle. As long as you get that order correct, you're definitely going to get these right. So one of the big skills is just making sure that we know which rule to use. We might have sine rule or we might have cosine rule. So for the sine rule, we need two angles and two sides, and one of those is going to be unknown. With the cosine rule, we're going to have three sides and one angle of interest, and one of those is going to be unknown. As long as you have those three sides, I would always just gravitate to the cosine rule first and then be like, ooh, this could use the sine rule instead. But three sides, cosine, two sides, two angle is going to be your sine rule. Thanks so much for watching, guys, and I'll see you later.